Hello everyone, my name is Matt Ruffner and I'm going to talk to you today about sampling k-nearest neighbor graphs for training set selection in machine learning. First, I want to talk about graph sampling and graph signal processing as a whole. Graph signal processing is a field that is emerging to process data which is defined on irregular graph domains. Current graph sampling methods rely on spectral decomposition and the graph Fourier transform, and these operations are based on expensive computations which determine the eigenvalues and eigenvectors of the Laplacian matrix of the data or the graph. So we actually use blue noise graph sampling, which is a vertex domain approach in which nodes are chosen as far away from each other as possible while still spanning the entire graph. As you can see, the center bottom graphic displays a good example of blue noise graph sampling, and on the right is adaptive blue noise graph sampling, and on the left is state-of-the-art optimal graph sampling. So this gives you an idea of how blue noise graph sampling is indeed a form of optimal graph sampling. And both of these use iterative methods to add nodes to the optimal sampling set. However, blue noise graph sampling is a vertex domain approach and is much more computationally efficient. My experiment is actually using this void and cluster algorithm, which is an implementation of blue noise graph sampling for training set selection in machine learning. So we want to choose a sampling set with blue noise graph sampling which accurately represents the distribution of the data. This way, when we train any neural network, I use a SVM classifier for simplicity. Any machine learning algorithm, it'll have a better idea of what the data looks like. So, like I said, I use a multi-label SVM classifier with MATLAB's fit CECOC command, and I compare the classification accuracy and variance in accuracy between runs for 3 different data sets. So I vary the sample density from 5 to 50% in 1% increments. For each increment, 50 iterations, sampling, training, and classifying are performed. I use data sets that are built in to MATLAB. I use Iris, Ionosphere, and Wine. They represent a few different types of data sets. For example, Ionosphere is a binary classification task. Iris has 3 classes. Wine has 3 classes. And these are all relatively small data sets. This was just to get an idea of the improvement that we might see from using blue noise sampling for train test set selection. And here you can see the results are pretty decent. We get improvement across the board for the most part for classification accuracy, and also a variance between trials for the Iris dataset at the top, Wine in the middle, and Ionosphere on the bottom. To summarize, we get a 13% increase in accuracy for Iris, an 11% increase in accuracy for Wine, and a 4% increase in accuracy for Ionosphere. And this void and cluster algorithm operates on the k-nearest neighbor graph of the entire data set. So obviously varying k for each data set can vary the results as well. Moving forward, I'm going to work on integrating void and cluster blue noise sampling with hyperspectral data and other visual data sets such as Indian Pines, Pablo University, Olivetti Faces. Again, these are looking to be a little larger of a graph, so I can test out some partitioning and really see the computational speed up that you get from using a vertex domain approach as opposed to the current optimal graph sampling methods which rely on eigenvalue decomposition. So thank you, and I hope you enjoyed.